factor!
Hey, this is JT. You're probably wondering how I got myself in this situation. Well, let me take it way back for you guys.
Yo, JT, do you know how to factor?
Dude, honestly, no.
Dude, how do you not know how to factor, bro? That's like so
Dude, I don't even know where to start, honestly.
Honestly, if I were you, I would start with the greatest common factor.
How do you do that?
Well, let me tell you. Dude, it's literally just the highest number that two numbers can multiply by. Alright, dude, say you're dealing with an equation and it has 4x plus 16. The greatest common factor in that would be 4, because both of those numbers can be multiplied by that.
Oh, so you're saying if I had an equation like 8x plus 64, I can factor out an 8 and get 8x plus 8, right?
Yeah, bro, exactly. So, do you know anything about reverse FOIL?
No, what's that?
Alright, so to reverse FOIL, you have to get the two integers. And the number that multiplies to get one of them and adds to get the other number. They both have to be the same number, and then you separated them into groups of zeros.
So say you had an equation like x squared plus 7x equals 10. If what you're saying is true, would the answer be x plus 5 and x plus 2?
Do you know difference of squares?
Oh, I know this one. Is that where you have an equation where it's like 25x minus 36, and when you factor it down, it's 5x minus 6 and 5x plus 6. But it only works with equations where it's minus. It does not work where it's plus, because there is no 5x plus 6 and 5x plus 6. You can't do that.
Yeah, that's exactly it, bro. Alright, that's good, bro. Do you know difference and sum of cubes?
I'm catching on, but can you explain it to me though?
Well, to know that, you're gonna need to know some of your perfect cubes.
Perfect cube? Oh yeah, I know.
Okay, well, do you know some?
Cube of 1 is 1, the perfect cube of 2 is 8, and the perfect cube of 3 is 27?
Yeah, that's good. You know them. Alright. I think in order to explain this one, we're gonna need to move to a different location. Alright, well, I have my notes here with me. Just, you know. The sum of cubes formula is a3 plus b3 equals parentheses a plus b, and parentheses start parentheses a to the second power minus ab plus 2 plus b to the second power in parentheses.
Well, why is the second equation so long?
Oh, because we're dealing with, cubes. There's going to be a lot more factoring that has to be done.
Oh, so since we're dealing with cubic x factors, that means that there's more factors that we have to plug into a separate equation. That's why the second equation's as long as it is, with the x squared and the other x, because we have to factor out so much.
That's good. That's real good. Now let me ask you a question. If you had x cubed plus 8, what would come next?
Oh, so if we had x cubed plus 8, would that mean that the answer is, in parentheses, x plus 2, and then the other parentheses, x squared minus 2x plus 4?
Oh yes, James, well done. That's good. That's real good, JT. Now we're going to be going over the difference of cubes. A to the third power, well, this is a formula, by the way, formula. A to the third power minus b to the third power equals, in parentheses, a minus b, new parentheses, a to the second power plus ab plus b to the second power and parentheses.
Whoa, whoa, whoa. For the difference of cubes, why is it that in the first parentheses it's a minus b, but in the sums of cubes, the first parentheses is a plus b?
Well, it's difference of cubes, so obviously you're doing some subtraction. So when you think of that, just remember that the first term has to have subtraction. But when you're doing sums of cubes, you're adding. So just that'll help you keep in mind that, put a plus sign there.
Okay, but for the difference of cubes, what about the second group of parentheses? What's going on there?
For the second group of parentheses, you need to keep in mind that the last term is going to be added at each one. But when you're doing let me get through this. When you're doing difference of cubes, that first little group in the second parentheses has to be added. Just keep in mind it flip-flops from the first term.
Well, I'm gonna put in my own terms, or try to, because I didn't really understand the way you explained the concept. So basically, for the difference of cubes, the second group of parentheses is strictly adding, because the only subtracting you're doing is being done in the first group of parentheses. Now for the sum of cubes, since the first group of parentheses is adding, you have to have some sort of subtraction going on in there, which is why the first two terms in the second set of parentheses, that's when you subtract. Oh, yeah!
Alright, JT. So in this concept, factoring by grouping, let me tell you, it can be a little difficult at times, but you need to get it down, because if you don't, either I or somebody else will find you and we are going to beat you up.
I'm sorry, teacher. I don't know if I can do this.
Listen to me. You can do this. I believe in you.
Okay.
Okay, so to factor by grouping, you have to have at least 4 terms. Then, the last thing you need is to have a term with the exponent of 3.
Okay, but can you explain it further? I'm still really confused about this topic.
Alright, let's just do a practice problem, see how you do. Okay, so these are your 4 terms. X to the third power minus x to the second power minus x minus 1. There's where the grouping comes in play. You take the first 2 terms in one group and the last 2 in another group using parentheses. But in the first group, you're taking out x to the second power, so that way that would be on the outside. And then you would have x minus 1 in one set inside parentheses, and then minus 1, and then the next parentheses x minus 1 again. And so to get to the next step, you take the both of the terms that are outside of the parentheses and put them into 1, and then what's left are the group in parentheses, and they're the same thing. So you would have x to the second power minus 1 in one set of parentheses, and then in the other, x minus 1. And then, using difference of squares, you would have x minus 1, x minus 1, and x minus 1, all in their own set. And all the zeros of those equal 1.
Look, teacher, I understand. I'm trying to understand what you're saying, but I really don't know what's going on.
You know what, JT? I told you, if you don't understand this, something bad will happen.
Now that you're all caught up, let's bring you back to present time.
Tell me everything you know about factoring!
Like, I know some stuff about factoring, like difference of cubes, sum of cubes, reverse FOIL, greatest common factor, stuff like that.
You better know factoring by grouping.
The one that I don't know. I don't understand factoring by grouping at all. Bad dream.
James! I'm glad you're up. Now tell me about factoring.
I know a thing or two about factoring.
Oh, yeah!
Remember, kids, know all your types of factoring, even factor by grouping. You know, factor by grouping is the hardest one, but with enough practice and our video, even you can know how to do all types of factoring.
Or else.